Hi, this is Sir CJ, and this is the 24th session in Physics 9. And welcome to another session. In this session, we are going to be kind of like looking back to your grade 8 classes because our main topic is work. And in work was something that you discussed with your teacher when you were still in grade 8 as a sophomore. Okay, so in this video lesson, we are targeting to finish the following activities. So the first one is observe discussion about work. And then we will be having a guided problem solving activity through a sample problem. And then you will be independently solving for your own problem and work on the third and last part of this session. Remember that this session is still in book number 21, unit 4. But this time we are going to be using pages number 4 to 6. Our target in this book is as follows. So we have to be capable of explaining energy transformation in various activities and events, such as in waterfalls, archery, and amusement rides. Let's dive in. When you were in grade 8, I think that you were already familiar with work. As it may be clear to you and familiar to you, the energy inside the batteries of, say, for instance, a toy car or a robot can make the car of the robot cover a distance and do some kind of work. Now, what will happen when you remove the source of energy for the toy that depends on batteries for them to move a certain distance? What do you think will happen to the robot? Will the robot or the toy car be able to do work if that's the case? Can they cover a particular distance? In grade 8, na-complete nyo na actually in discussions related to the concept of work. In its everyday use, it may actually mean the tasks that you need to do, like ang pag-aaral ng mga lessons, yung paggawa ng mga homework mo, o kaya yung paghuhugas ng mga plato. Now, in other ways, it can actually refer to maybe an occupation or a job such as selling, o kaya pagtuturo, o kaya healing, and constructing houses and buildings. Now, in physics, work can actually mean the product of force, the application of force that is acting on an object, making it cover a distance or displacement. So, para sa work, for work to happen in the world of physics, kailangan yung in-apply na work, na force, I mean, is going along a particular distance. Kapag halimbawa, nag-apply nga ng force, halimbawa, you're applying force when you're pushing a wall, pero it's not actually moving, you're not actually doing work. Okay? But when you push a cart full of grocery items, since nag-exert ka ng force para ma-push mo yung cart, and yung cart naman in turn is actually moving, it's covering a distance that is similar dun sa application ng force na in-apply mo. Halimbawa, kung tinutulak mo siya paharap, yung cart mo is actually moving forward. Okay, so the application of force was forward and the distance covered by the cart was also forward, then that means you are doing work. Okay, pero pag halimbawa, you are pushing the cart, but the cart seems to move in a different direction, like say for instance, it's moving backwards or upwards, well, you're not doing work in that case, okay? Now, mathematically, work can be represented as the product between force and displacement or distance. Okay, so work or W is equal to F times D. Ayan. Now, let us have a recap of this past lesson by using this formula in the sample problem that will follow this task. Alright, for the second part of this session, we have a sample problem. Say for instance, one of my cousins, Jerome, joined me in my random shopping spree in Pure Gold supermarket. Now, since I am busy looking at labels and he does not have an idea how to do grocery shopping, he is tasked to push the cart. Now, how much work is he doing if he is exerting 400 newtons of force to the cart that made it cover 5 meters worth of distance? Okay, so I will let you try and solve this problem, but first let us list the givens. Okay, so ano kaya yung mga givens? Please take this time to list them down on your sheet of paper. Go ahead. Are you done? Let us now cover the givens. So the force that was applied was 400 newtons, and then the cart covered 5 meters of distance. And it wasn't going in the same direction of the application of force, so we can say there was work done, and now our task is to solve for it. Okay, so make sure that you're labeling your givens properly. Very good. With the units? Very good. Let's now proceed with the solution. In the solution, always remember that we are starting with the base form of the formula. What do you think is it? Write it down. Is it this one? Very good. Now, your next task is to substitute the given factors. Please, substitute the given factors. Make sure na mayroon silang mga units, okay? Did you do it? All right. So for the factors, we have 400 newtons worth of force and 5 meters worth of distance. Now, carry out the operations. Are you done? You can use your calculators. Okay, write it down and label it properly. Jerome actually applied or did 2,000 joules of work. Now, what is joules? Joules is equivalent to Newton meters. Okay, and it is the kind of unit that we are using to represent work. Ayan. So let's now proceed with the next problem, and this time you're gonna be solving this yourself. You'll be independently solving for this yourself. So the problem is, I took the card from Jerome when we were about to go to the counter so he can pick up one bottle of sweet and sour dipping sauce from aisle number 19. Now, I exerted 450 newtons of force to make it to the counter that is 9 meters away. Now, how much work do you think did I do? Now, make sure that you are listing down the givens properly, and then you are also putting the units properly, and you're labeling them, and make sure that you also include the missing factor. Now, for the solution, you have to do what we did in the previous problem. Okay, now you may pause this video for you to have more time. Are you done? All right, let us check. Please check your work. This is the correct answer. So the thing is, I did 4,050 Newton meters of work, or you can also say 4,050 joules of work. Did you get it correctly? Give yourself a pat on the shoulder if you did. Very good. Now, this is the last part of this session, and remember that in this session, we finished the following things about work. So we discussed it, we had the problem solving that is kind of like guided, so you can, have a feel of it. And then we also did an independent problem solving activity as the last part. Now remember that this is based on the 7E-based self-learning module in Science 9, which I wrote for my master's degree, particularly in Unit 4, book number 21, pages 4 to 6. Now, our aim in this video lesson was to be capable of explaining energy transformation in various activities or events, such as waterfalls, archery, and amusement rides. This is Sir CJ, and I hope that I will see you in the next video lesson.